Welcome back to VQ Intel. In today's video, we're going to be sort of continuing the last video where we talked about compound inequalities, and we're going to be focused a little more on rational inequalities. If you want to follow along, links to the companion worksheet are in the description below. Now, with all of these, we have a rational inequality, so we need to start with a sign chart. But in order to do that, we first need to factor this. Now, the top is already factored, x minus 1. But the bottom needs to be factored. X squared minus 4 is x plus 2 times x minus 2. And that is all less than 0. So first step in our sign chart is find what values of x make it 0. That is what makes just the top 0. So that's 1. Next, what values make the bottom 0? That's going to make it undefined. And that's negative 2 and positive 2. So now what we have is we have 4 intervals, and we have to test them all. So over here, if I plug in negative 3, I've got a negative on top. And I plug in a negative 3 here and here, I've got a negative on the bottom and on the bottom. So that's a negative. Over here, if I plug in something like 0 up here, that's a negative on top, positive here, and a negative here. So that's a positive. If I, over here, plug in something like 1.5, so that's going to be a positive. That's a negative. That's a positive, that's a negative. So a positive over a positive times a negative is a negative. And then finally, over here, if I plug in 3, that's going to be a positive, and a positive. So that whole interval is positive. Now, what are we interested in? We're interested in the parts that is less than 0. So that is these two intervals here. So that is x is less than negative 2, or 1 less than x less than 2. Or in interval notation, that's negative infinity to negative 2, union 1 comma 2. All right. So the next one, again, we need to factor the top and we need to factor the bottom. So the top is going to factor into x plus 4 and x minus 3. And on the bottom, this is going to factor into x plus 2, nope, x minus 2, sorry about that, and x minus 2. So what values make the numerator 0? That's going to be negative 4 and 3. What values make the denominator 0? That's going to be 2. So now we have 4 intervals to test. But the thing to remember is here this is x minus 2 times x minus 2. So we could think of this as x minus 2 squared. Well, anything in the bottom is going to be positive automatically. So we can sort of not worry about that. We can just say, yep, the bottom's always going to be positive. So if I plug in negative 5 here and here, that's going to be negative times negative all over positive. That's positive. Over here, if I plug in 0, that's going to be positive times a negative all over a positive. So that's going to be negative. Between 2 and 3, so 2.5. So that's going to be positive, negative, and positive. So that's negative. And then over here, if I plug in 4, that's positive over positive, and the denominator is still positive. So I want the intervals where it's greater than or equal to 0. So I have to include these numbers here. So my two intervals are x is less than or equal to negative 4, or x is greater than or equal to 3. And in interval notation, that's going to be negative infinity to negative 4, union 3 comma infinity. So for the next one, we need to factor the top. And so the top is going to factor, if we take out an x, we're left with x squared minus 4, which factors into x times x plus 2 times x minus 2. Now the bottom can't be factored when it comes to real numbers, and we're only dealing with real numbers here. Now the thing to remember is that, like the last one, this one is always going to remain positive. And so this time, I'm pretty much just not even going to worry about that. Since it's positive, it'll never, ever equal 0. Because no matter what you plug in, the lowest it'll ever equal is 4. Because x squared could be 0. So since this will never be 0, it will never be undefined. So all I have to worry about are the values that make the numerator 0, which makes this whole expression 0. So, since the bottom is 0, since the bottom is always positive, I'm going to pretend it's not even there, because it's not going to change signs at all. So if I plug in negative 3, that's going to be a negative times a negative times a negative, which is negative. Here, if I plug in negative 1, that's negative times a positive times a negative. Over here, if I plug in a 1, that's a positive times a positive times a negative. And then over here, that's a positive times a positive times a positive. So I want the intervals where it's strictly negative. So that's these two intervals right here. So x is less than negative 2, or 0 less than x is less than 2. In interval notation, that's negative infinity to negative 2, or 0, comma 2, parentheses like that. All right. So over here, when we make our number line, the values that make this 0, the top, are 0 and 2. The values that make it undefined are negative 3. Now the thing to note is that this is squared and this is squared, which means both of these are positive. So really the only thing we need, so these aren't going to change signs at all. The only thing that will change sign is this factor right here. So anytime you have something that's positive, you can pretty much just ignore it as long as it will never change sign, which these never will. So all I'm going to worry about is I have 4 intervals to test, but I'm just going to plug them into negative 2. So let's see, negative 4, that's negative. Negative 1, that's negative. 1, that's negative. 2, that's a positive. There we go. That's it. So I want all the intervals where it's less than or equal to 0. So I have this interval, and then I have this interval. So I have x is less than negative 3, or negative 3 is less than x, less than or equal to 2. So I have negative infinity to negative 3, or negative 3 to 2 with a bracket. Now these last two are rational, but what we have to do is we have to first write them with a common denominator. So I need to put these two together. So I need to rewrite this as x cubed over x minus 2 over x. So when I put these together, I have x cubed minus 2 all over x is less than 0. Now, what value makes the top 0? Well, most people will look at it and say there isn't. Well, actually there is. And that is the cube root of 2. Now, what is that as a decimal? Not sure. I know it's bigger than 1 and less than 2. I know that. Now, what value makes the bottom 0? That's going to be 0. Defined right there. Now, I know 1 is in here and 2 is over here, just as a little marker. So what if I plug in negative 1? Negative 1 cubed is negative 1. Minus 2, that stays negative. So that interval is going to be positive. If I plug in 1, 1 cubed is 1, minus 2 is negative. That, oops, negative. And then over here, 2 cubed is 8, minus 2 is a positive. All over 2. So I want the intervals that are positive. So that's this and this. So x is less than 0, or x is greater than the cube root of 2. In interval notation, it's going to look like this. Last one, same thing. We need a common denominator. So here I'm going to multiply this top and bottom by x minus 3. And I'm not going to multiply the bottom out. It's just going to make it easier for me when I do the sign chart. And this I'm going to multiply by x plus 1, top and bottom. So I have 2x minus 2 all over x plus 1, x minus 3, less than or equal to 0. So then I factor out a 2. So now I can fill in my sign chart. What makes the top 0? That's x equals 1. What makes the bottom 0? Negative 1 and 3. Now I don't need to worry about the 2 because the 2 will never change sign. So over here, if I plug in negative 2, that's a negative all over a negative times a negative. That's negative. Over here, if I plug in 0, that's going to be a negative times a positive times a negative, which is a positive. Here, if I plug in 2, it's going to be a negative. Whoops, that's a positive. Negative, or no, positive there, and a negative, so that's negative. And then over here, positive on top, positive, positive. So I want the intervals that are negative or include 0. So that means I want x is less than negative 1, or negative 1 less than or equal to x less than 3, or in interval notation, negative infinity to negative 1, or negative 1 with a bracket to 3. All right. Thanks for watching. If you want to support the channel, the links are down below. Thanks so much for watching, and remember, the best way to understand something is to do it.